The next topic of interest is going to be graphical transformations. Graphical transformations are mathematical operations that are applied to graphs. So although this is going to seem unnatural, what we're going to be doing is we're going to be applying basic operations of multiplication, subtractions, and addition to a function in a very specific way. And for each mathematical operation, it's going to change the graph. Change the graph, in other words, it's going to transform the graph. Transform, change. So basically, when we start off with transformations, we need to start off with the most basic graph. Now, I'm not going to say always, but generally speaking, we'll start off with the most basic parabola, and the most basic parabola is y is equal to x squared. A is equal to 1. The vertex can be found at 0, 0. And now, what's our destination for the whole topic? It is to create a graph, or any parabola, that can be written in the form y is equal to a, open brackets, x minus h, close, squared, plus k. So I'm going to ask you to take a look at here and try Desmos. And you're going to try Desmos, and you're going to enter the equation y is equal to a, x minus h, close bracket, squared, plus k. A, h, and k can be found in the letter menu. And then when it comes time, you're going to select all sliders. And you're going to play with the sliders and attempt to determine the effect on the graph. So there are two categories of transformations, shape and location. So let's look at A, H, and K. And we're going to identify which parameter, A, H, and K, what they affect, what affects the location of the vertex, and what affects the shape of the graph. So I'm just going to type in y is equal to a x minus h squared plus k. Now, if you notice, there's nothing special about these letters, but I'm going to add sliders to all of them. And initially, I'm going to move h to 0 and k to 0. In other words, if h and k are equal to 0, this is going to be the location of my vertex. So there we are, close enough anyways. Now, what we notice as A gets, what does A do? Well, A really controls how thin or thick our graph is. Now, that's actually technically wrong wording, but there you are. That's what A controls. Now, I'm just going to move my slider, so when A is 7, graph is fairly thin. But now I'm just going to move A to the negative. And what we maybe see when A is negative, oh, our graph is downward opening. And we probably knew that from before. So I'm just going to put A as 1.8. And now I'm just going to change the H. Well, what does H do? Well, H changes where the parabola is, but only horizontally. And K is going to move our parabola up and down. So really, let's just get back to this. Now, this may not come as a surprise. A controls what our graph looks like, the shape. H and K are going to control the location. So let me just move H and K. The shape of the graph will stay the same. It's just simply the location. So there we are. Now I'm just going to maybe move this into sight. I'm going to move A. All A does is simply determine the shape. So getting back to where we were, what determines the location? A, H, or K? Well, the location of the vertex is determined by HK. Exactly your thoughts before. The shape is only determined by A. I would encourage you to read these definitions and try to work these into your vocabulary before we go on to our next examples.